you take a look at the back of your regular cheat sheet, you'll see a section titled Electron Configuration Notation. We're going to do electron configuration notation and a second one called noble gas notation today, which is going to bring our grand total of notation skills to 3 different ones. But let's start with electron configuration notation. Now, all this is another way to write the same thing. If you look here, I already have the orbital notation for nickel written on the board. All right? The long, annoying, draw lines, draw arrows, takes a long time. Electron configuration notation is a bit shorter, which is nice. All the same rules apply. Let's pretend that we're doing nickel again. Normally, we wouldn't already have a blueprint of orbital here, but I'll show you how it does represent the exact same information. Right along with me, first off in your notes, put nickel equals 28 electrons so that you can see what we're writing the electron configuration notation for. But watch how it's easier. Off-ball says that we always start with 1s, right? So there's my 1s. However, I'm not going to draw a line. I'm not going to draw any arrows. Instead, I'm going to represent the number of arrows electrons that I would draw by using an exponent. 1s2. Exact same info, less annoying. And right after 1s always comes 2s. And how many electrons did I draw in my 2s? 2. So 2s2. After 2s always comes 2p. Of course, you can get this off your cheat sheet. And now this will be a different number. How many arrows did we draw for the 2p? 6 total. 2p6. Again, I don't want your brain to think this is something new. It's the exact same info. From 2p comes 3s. How many electrons did we draw for 3s? 2. After 3s came 3p. How many electrons did we draw for 3p? So 3p6. Very repetitive, right? After 3p came 4s. And there's 2 electrons there. But now this one will be a little different. 3D is next, but you don't want to fill them up. What's the biggest exponent we could put there? We could put a 10 there. All right, the biggest one that could possibly fit on 3D would be a 10. But for nickel, we didn't draw 10. We only drew 8. This is the entire answer for electron configuration notation, as your cheat sheet also clearly shows you. And even if you like that step where you count the arrows to make sure it equals the right number, you can still do that. Just count the exponents now. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 8 is 28. So you can still check your work. And it's a lot less writing, right? Let's do one from scratch together. How many electrons does cesium have? 55. Now, normally that would be a pretty annoying number. Because if we were having to do orbital notation, and make sure you can recognize these by their names. If we were having to do orbital notation, we'd have to draw 55 arrows. But we're not. We're going to do electron, I should have already wrote this, sorry, electron configuration notation. Now, we're doing this one from scratch. We don't have a blueprint to go off of like on the last one. So, make sure you've got this cheat sheet in front of you, the secondary one with the energy levels and sublevels on it. And I'm going to show you that it's even actually easier than seeing how many orbitals an S has and whatnot, because we get to count squares. Let me show you what I mean. Where are we going to start? In unison, where are we going to start? Where are we going to start? Hey, there they are. I love it when there's a class here. Yeah. We're going to start with 1S. Now, here's what we could do. Look, give me your eyes. Give me your eyes. Quit working ahead of me. I'm glad you're brilliant. Normally, we would say, how many orbitals does an S have? How many electrons fit in that orbital? And we would agree that overall 2 would. But there's another way to do it. Look at your table here. Look at it. How many 1S squares exist? 2. Don't let helium trick you. There's 2 1S squares. They're just split. But those 2 numbers will always coincide. Even with the orbital notation, they were the same thing. That exponential number, that exponent there, is always going to match the number of squares in that block. 1S has 2 squares. What comes after 1S? 2S. All right. And how many squares does 2S have? There's 2. Does everybody see how I'm seeing that? Everybody see how 2S has 2 squares? Well, that is the number that goes there. After 2S, as you read your book across, comes 2P. Hey, look, count the squares. Count them, count them, count them, count them, count them. How many 2P squares are there? There are 6. Now, normally we would have said, well, 2P has 3 orbitals, and each of those orbitals is holding 2 electrons, and there's 6. All right? It's all the same science. We're not doing anything different. I'm just showing you that you can just count squares also if you don't want to run through that process every time. What comes after 2P? 3S. And there are 2 squares in the 3S block. Now let's pause real quick. Do a little comparison between your real periodic table and your other periodic table and find cesium on the unlabeled one. And I want you to tell me, what block does cesium actually live in? He lives in 6S. If you do a comparison, you can see that he lives in the 6S block. Now, in that 6S block, there's 2 squares, right? Which square is cesium, the first or the second? Look at this. I know exactly where my ending configuration will be already. We need to work through the chart until we get to 6S1. And that will be cesium. You don't have to do this preliminary step to find out where you're going to stop, but it's nice. You don't have to keep counting to make sure that you're hitting 55. But let's keep going anyway. After 3S, I see comes 3P. P's got 3 orbitals. Each orbital holds 2 electrons. 3 times 2 is 6. Or, of course, you can see that there's 6 squares. After 3P comes 4S. 4S contains 2 elements. After 4S comes 3D. How many squares are in that 3D block? There's 10. Count them. Or, of course, we know that D has 5 orbitals, and 5 times 2 is 10. And now let's keep going. We're not to 6S1 yet. After 3D comes 4P. How many squares are there? 6. After 4P comes 5S. Stop me if you don't know where anything comes from. How many squares are in the 5S block? 2. Or, of course, S has 1 orbital. That 1 orbital can hold exactly 2 electrons. After 5S comes 40. 4D. What's my exponent here? 10. After 4D, keep going across, I hit 5p. A p has 3 orbitals. Each of those 3 orbitals can hold 2 electrons for a total of 6. Of course, there's 6 squares. After 5p comes, hey, look, success. Get it? Success. Success. You don't care. Okay. We're stopping here, right? Because we knew nice and early that we were going to be stopping here. Or, if you didn't do that part, verify at the end. We're trying to hit 55. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30, plus 6 is 36, plus 2 is 38, plus 10 is 48, plus 6 is 54, plus 1 is 55. Success. Do you like this notation better than orbital notation? Yes. You should like it better. All right? Don't discard orbital notation. All right? It's a fifth of your test next week. All right? 20% of your test will be over orbital notation. But another 20% will be over electron configuration notation.